Hello and welcome back. We were solving problems on projections of solids, and we are going to continue with that problem. Just for a sneak peek, let's look at the problem once again. This was a solution that we had drawn. The solution for which we were drawing was a cone of diameter of base 60 mm and 70 mm was the height, as one of its generator in HP and making an angle of 45 degrees with VP. Now there are two conditions in which the projections have to be drawn. The apex is towards the observer and the apex is away from the observer. So I will draw one of the solutions as correct, and I'll show you the other so that we can solve more number of problems, because the solution is simple. So till here we had solved, we had drawn this, and we have inclined this to the, it is lying on its generator. This is its generator, OE, and which is again lying here. So this is the generator which is lying on HP. So this is what has been done so far. Now what we need to do is that this axis has to lie 45 degrees with respect to this line, which is considered to be as VP when we are drawing the top view. Now there are two cases. In one will be the observer will be observing always from here, so this apex one will be pointed in this direction, and in the other solution it will be pointed in this direction. So we'll draw in which the apex is pointing towards the observer, that is me. Right now I am the observer, I am sitting in the this side. So what I'll do is that I'll draw the apex here and the base circle somewhere here. So that will make it this section, and if I exactly reverse it up, then the other solution would be obtained. So what I'll do, I'll draw a line at 45 degrees first, and then I'll draw a line at 45 degrees. Okay, this is 45 degrees. So I'll just extend the line, and I'll assume this point to be my apex. This point I will assume to be my apex. So accordingly, what I'll do is I'll mark these 2 points first, A and E, that are at particular distance and on line with this. So this I'll do, I mark this point as C2, and the same point for A that I'll do is this. Okay, now I have A and C, so I can mark G, which G and C, which will be there on and it will be cut by this, so it goes perfectly. And even these 2 points, first F and D, and for G again this will be marked on this end. Now we need to do is that find this distance, that is C to F, put my point here and cut the points on both the ends. Put it here and again cut at both ends. Okay, and I just need to extend this arc a bit, which was left down, so this cuts here. So I have all the points which I wanted on my periphery of the ellipse. These are the points that will make up my ellipse. So I will just smoothly curve it up. I will use say blue pen. Okay, and connect the endpoints as well. And of course the observer is here. Okay, let's mark the points. This is O2, starting make them a bit dark. Point is towards the observer. So let's see. Let's start by naming this point as, okay, how we need, what we'll do is we can assume any number, any kind of this, but according to what we assume, or what we will take, we'll take it in a proper order. So the thing is that this point we will consider it as A. So if we consider this as A, then it will be more clear that how it will be. So this is A2, B2, C2, D2, E2, F2, G2 and H2. Now let's extend these lines upwards. So the point O will be here only, black pen, yeah, point, this is O2 dash. F and D. So where is F and where is D? So I have D here and F here, so it will be in this line and this line. F was here, so this line. D was here, so this line. Projectors also I will draw so that it's clear. G and C. G is on this line, and where do I find C? C is on this line. B and B is here and H is on this line. And finally I have this A here. So the line which I'll have as my full line would be this. And then this will be the dotted line which will be actually behind the points which will be there. And finally I will join these points to have my figure. And if I, instead of keeping it this way, if I invert it in this way, if I do it, sorry, not rotating the paper, that would be difficult. If I just forget this all right now and just invert this paper, then in that manner the result that will be acquired will be exactly the solution of the second problem, in which this strip will be away. Means this has to be exactly flipped, so this will also get flipped. The rest of the problem remains the same. So you all do that on your own, and let's move on to the next question. You can note down the question, and I'll give you the page number on which the solution is given for this, because we want to begin with section of solid, and this is a problem which can be solved by you, and because we have drawn a lot of solid projection of solid problems, so this solution can be drawn by you. And the page number on which the solution is given, I've taken this reference from this Professor P.J. Shah, that is this book from S. Chand, Engineering Graphics, and it is given in the new book on page number. I'll just mention the page number. The page number is 213, problem number 37, so you can refer to this problem there. So let's begin with sections of solid. Now, what are sections of solid? We have studied solids. Now the basic difference between solid and section of solid is that they're both basically a three-dimensional figure. Now if I have a solid and I have a knife, if I cut it out, then what happens is that okay, this is the best example. If you can zoom in, to this, if you can zoom into this glass, it will be a very good example of it. See, if I take this as a cylinder, you can see that this is the top part of the glass, and which is, we can say, the top surface. This is the bottom surface, and this is its body surface, as we can say. Now what will happen is that if I take a plane and then cut it, then there will be another layer rather than top layer, which will be visible by the level of the glass. If I shake it, you will be able to see this is the level of the glass. So if I take a plane and I cut it exactly from here, so what will happen is I'll be able to see the this level of water, exactly what it is. So this will be the thing that will be visible to me, and this part will be extracted up. Now if this is at an angle, see, if I'll drink it a bit. Now if I keep it this way, what has happened is that, okay, have a plain background, yeah. So what has happened is that I cannot rotate water. So what I did is I rotated the glass. So if I say this is a straight cylinder and this is a plane by which the cylinder is being cut, and if we see it from this way, then you will see a kind of ellipse which will be there, which is actually the section when I am cutting this exactly from this way. So that is known as sections of solid, which is there. Now let's take a look of the different sections and the planes which are available. The first is horizontal cutting plane, which we saw. Then the next is a vertical cutting plane, which is parallel to VP. Then in the next we have cutting plane parallel to the profile plane. Then auxiliary plane, which is parallel plane, and auxiliary inclined plane. So these are the common types of section planes for which we are using the cutting planes. Okay, now examples, typical examples of sections of solid. This is a section of a cone. Now what has happened is, okay, I have used a plane, section plane, through the apex. As you can see in the orange figure, there is a plane that is there in the dotted line, which has been shown through an arrow as section plane through the apex. When I remove the left hand side of the surface and see it from that side from which the arrow is coming on the orange, a triangle in the green will be visible to me, as you can see on the right hand side or in the green, and the cone which will be there will have a section in which this will be a triangle that will be visible to you. Okay, now if I am cutting a section through the generator, both the generators, I am cutting both the generators, one is here and one is here. So these are the 2 points on which I am cutting this plane, and both the generators are being cut, and the apex is basically off. So if the cone, if I look it from the top, then it will look something of this sort, in which this will be an ellipse, which is an isometric view of this, where all the dimensions are visible to you. So this is an ellipse that will be seen on your screen. No, not on your screen, but on the solid, and which has been chopped off using this plane, which is passing through both the generators. Okay, now if the plane is parallel to the axis, then what will happen is, then something of a hyperbola sort will be formed. If I remove this part and view it from here, from where my right now my cursor is here, so I'm viewing it from this angle. So if I look at this section which has been chopped off, then this green section is actually what is the section of solid which is visible to us, and the rest of this is actual cone which has been left after cutting the cone. So this is known as section of solid when we are using a section plane parallel to the axis. Now if it is the plane is parallel to the end generator, then something of parabola sort would be formed. Now again, cutting a cylinder through both its axis, to both its end of the faces, ellipse will be visible. Now if this is a pyramid, a square pyramid. Now in this square pyramid, again if I cut it from both the edges, then something this plane which is seen to us will be in form of a trapezium. If it is a cylinder, then it will be an ellipse. Otherwise, if it's a square pyramid, in this case it will be a trapezium. So I hope you understand what you mean by section of solid. So let us solve two problems which will make it more clear on your part, so that you will be able to solve the problems more easier. The first problem, now this is a simple problem that we are taking up. a hexagonal pyramid which is of base 30 mm and height 63 mm is resting on HP on its base with two edges of the base parallel to VP. So it says that two edges of its base are parallel to VP. So one of the corners will be in HP, as we can as we'll be seeing it when we'll drawing the paper, drawing the solution on the paper. Two of its bases parallel to VP. It is cut by horizontal section plane passing through a point on axis 27 mm from the apex. From the apex, it means that if we start from the top and move downwards, then we have to move 27 mm downwards, and then at that point, say if this is the cone, so I'll just this is one of the edges of the cone, and this is the axis. What we have to do is from this point we have to move 27 mm downwards to this point, and then the cone the plane will be cut at this section. So what they want is what will be the views, the different views that you will get after the section has been chopped off. That is what basically we are going to draw on the paper right now. So let's begin. The first step will always be drawing line XY. Now this line XY is there, so we'll first of all draw the top view, which is a sectional pyramid is there. So a top view will be first of all we will be seeing a hexagon. So first of all I'll draw a hexagon. Now again I am going to use a rough dimension to draw it, so that I can, so I'll draw it at the center because there is only one figure. 30 mm, 30 mm, 30 mm. I'm drawing it freely, but you should always in the examination you should always follow the proper method to draw this, so that you have a highly accurate solution. I'm drawing it with a sketch pen to just make you illustrate that what is the